Hi, my name is Steven, and today I will talk about how to calculate a multi-mobility index. First of all, I'd like to briefly go over what is MMI. MMI uses to predict the prognosis of patients from their diagnostic history rather than the physiological markers. What is good about it is it uses each diagnosis as a separate independent variable using the individual International Classification of Disease codes or ICD-9 code. This method uses cross-validated where it's using 80% for training and 20% for validation. It has shown to outperform previous approaches with greater accuracy, for instance, quant variant of the Johnson index or the von Waraven variant of the Elixhauser index. Derivation of the multi-mobility index uses naive Bayes data mining method. It assumes that the impact of each disease on the mortality is independent from each diseases. Below are the two formulas that we use to calculate the probability of the mortality. The first formula, patient's score, it is how to calculate the product of our likelihood ratios, where the L diagnosis indicates the likelihood ratio associated with the diagnostic code in the training dataset. The likelihood ratio associated with each diagnosis can be interpreted as the number of times the diagnosis increased the odds of mortality. For instance, if the likelihood ratio is 2, it's indicating that the diagnosis doubles the risk of the mortality, whereas the likelihood of 0.5 is indicating reduced by 1/2. This slide will show us how to use naive Bayes to predict the probability of the mortality, or what are the chances of a patient that will die in a certain amount of time. Let's say we want to predict a patient, what the chances that the patient will die within 6 months, 12 months, or 5 years. The formulas below show how to do just that. The posterior odds is the probability where you get the prior odds, you multiply the MMI, which is a multi-mobility index. After that, you're going to get the posterior odds divided by 1 plus posterior odds to find the probability of mortality. And I will go over all these steps in the future slides. So let's put all this into perspective. Let's use a case where we have a 79-year-old female patient with pain diagnosis during the last hospital admission. And we want to find out the probability of this patient of dying in the next 6 months. The first step is we like to find out the likelihood ratio of each diagnosis that this patient has. There are two steps that we can do it. The first one, which we can look up the likelihood ratio using the data that has prepared by Dr. Alemi and his colleagues that posted in the Dataverse and in the George Mason University. Or if you like to be more technical, you can calculate the likelihood ratio yourself using the SQL. After you get the likelihood ratio for each diagnosis, you want to apply that to the first formula that we went over in the previous slide, where you're going to multiply all the likelihood ratio for 10 diagnoses to get the answer. What we're going to call is A. The third step is to calculate the posterior odds by using the answer that you have in step 2 and multiplies by 0.06. 0.06 is the constant. And the last step is to calculate the probability of the mortality using the result in step 3 divided by the result in step 3 plus 1. So here is the table that I have prepared for the 10 diagnoses that the female patient has, and it shows the description of each diagnosis and also the likelihood ratio for each diagnosis. So this is the technical part for anyone that like to try to calculate the likelihood ratio using the SQL. So first of all, if you have a data set, and this is code I'm using from the data set that we have prepared in the class. So first of all, we need to remove all the errors in the data set by removing all the patient that had already died using this code right here. And we put in a table called Q1. Next, we're gonna remove all the duplicates using select distinct. Select distinct will enable you to remove duplicate values or repeating IDs and ICD-9s. And we call this table A. We're gonna inner join with table B, Q1 from the previous table that we made with this ID from A and B equal to one another. Next, after you have removed all the duplicates and removing all the errors, we need to calculate number of dead and alive patients. First of all, we need to select ID and name this ID as all patients. What I want to point out is the statement that we're going to use here is the if max age at death is not null. If it's not null, we're gonna, meaning if the patient is dead, we're gonna give it a 1. If not, we're gonna give it a 0 and name the column as dead. Same thing with the patient as alive, and we're gonna put it in another table called table Q3. So after we have calculated the number of dead and alive patients, we need to sum them all up using the sum statement. And here is the SQL code that I have, and I put this table and name it Q4. After we sum up all the dead and alive patients, now we want to calculate the dead with diagnosis and alive with diagnosis. So here's the code for that. What I want to point out is that 0.5 meaning 6 months, because we want to predict the chance that the patient will die within the next 6 months. So there are 12 months in a year, 0.5 meaning half of that, so 6 months. And after that, what you're going to do is you're going to cross join, join the two tables together from Q2 and Q4. And having count here greater than 29 meanings we want to have include the patients that have more than 30 diagnoses and ordered by ICD-9. So after you have prepared the table, before you calculate the likelihood ratio, you want to randomly select 80% of the data for training and leave the 20% for validation. So this is the code that I use using the order by new ID. So once you have your data set that you picked out for the training, then you can go ahead and calculate the likelihood ratio. And this is the code for it. And what I want to point out is that we're using the statement cast as float, meaning the reason why we do that is to prevent any errors when you try to divide by 0. And you're going to put that into another table called train 1. So after you have calculated the likelihood ratios for the 10 diagnoses that the patient has, we can go ahead and proceed to step 2 to 4. So as you remember from the previous slide, the first step is we need to calculate the product of all the likelihood ratios. So what I have here, by calculating the product of all 10 diagnoses, we have 482.094. From that, I can go ahead and calculate the posterior odds using the constant 0.016, and I have 77.35. The last step is to calculate the probability of the mortality, and I have 0.987. So there's a chance that the patient will die in the next 6 months. The likelihood ratios that are above 1 indicate that diagnosis that increased the odds of mortality. So out of the 10 diagnoses that the patient has, lung cancer, secondary malignant neoplasm, acute myeloid leukemia, and cardiogenic shock contributed to the high probability of the mortality. Here are the references that I have for you. And that's all. Thank you for watching, everyone.